Alright, so I wanted to shoot this quick walkthrough of basically getting started and building and running the AUV software on your local machine. Here I have a native install of Ubuntu, and I'm just going to take it from the top basically. Okay, so let's see. First things first is let's download all of these files that are on GitHub. So here I have the repository open, and what I need to do to get all these files onto my local computer is I need to clone this repository. There's a couple of ways of going about this. As you can see, I can do this over HTTPS, I can do this over SSH, and I don't know what this third one is. I'm just going to stick to these two. So this is probably the simpler way. Basically, you'll authenticate with your username and your password, and you'll download the content that way. This is the way that I recommend and that I'm going with. It requires a bit of setup where you first have to generate and upload a key, essentially. But after that, your computer is able to kind of automatically authenticate you onto GitHub whenever you make requests there. Okay, before we do that, we gotta make sure we have Git installed. So when you're working in Linux, you're more likely than not going to be working off the terminal. I'm not really going to go over a lot of the commands, but suffice to say that it's good to get acquainted with some of the more common ones. Okay, so here I am in my home directory, and what I'm going to do is I'm going to just install Git. Git is the version control software that is kind of the backbone of GitHub. Of course, you don't need to, have access to GitHub to use Git. So right now, and you can see I don't have Git, but it handily tells me that if I run sudo apt install git, then that's how I can install it. Before running this, I'm actually going to do this sudo apt not install update. And what this would do is on your computer there's basically a list of servers that contain all the various different programs that your package manager can install, and it basically updates. It reaches out to those servers and basically asks them like, hey, there are any like additions or changes to the list of packages that you have? So yeah, basically you just like update them so now you're aware of the most recent packages. It's always just nice to do, especially if it's a fresh install. So okay, sudo apt get install git. Okay, and that's fine. Now, while that's going, I want to set up my SSH keys. So if you ever, I guess, want a concrete kind of tutorial on how to do this, GitHub SSH key. I believe, yeah, GitHub has a nice tutorial you can follow. So, okay, we are going to copy this command. SSH keygen will essentially generate us a public-private key pair. And then we would take our public key and we would upload that onto GitHub. Okay, and I'm just going to enter my email address. Of course, I think this is optional, but this isn't actually even my email address, but whatever. Okay, save the key. So right now it says I'm going to save it in the .ssh under id ed blah 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 blah. Yeah, I'm sure that's fine. I don't want to passphrase, that's fine. Okay, so let's check what we have. If we do ls-all, we see that we have this .ssh folder, and if we go inside it, we'll see that we have this public and private key. So if you're not familiar with public-private like keys, I would recommend the thing to Google would be asymmetric encryption or asymmetric authentication. I don't want to like speak too much about it right now, or actually maybe I will. Essentially, this is something that you'll see maybe come up a couple of times during this video. Essentially, you're dealing with the problem where you are talking to some kind of server out on the internet and you want a way to verify that the server is who they claim to be, right? Because like, I think I'm talking to GitHub right now, but like, what if this is just some middleman who's like pretending to be GitHub? How do I really truly authenticate that that's GitHub? And in turn, how does GitHub truly like authenticate that I am who I say I am? I'm not just like some imposter. Well, one clever way of doing this is you have basically these mathematically generated keys, and basically the act kind of like locks where you'd use one of these keys to quote unquote to encrypt a message, and the other one to decrypt it. And so there's this like asymmetric encryption. You can't use the same key to encrypt and decrypt. So in other words, I have these two keys. This is the private one. The private one I keep private. I don't tell anyone about this. I don't ever show anyone this key or the contents of it. And then the public key, here are the contents. Anyone can see it. I'm going to give it to GitHub. And when I'm connecting to it, I'm going to basically encrypt some message with my private key. And remember, only my public key can decrypt this message. And so, of course, GitHub will be able to do this because they have my public key. But the fact that they were able to decrypt this message and see what the message is means that I must have been able to encrypt it in the first place, which means I must have had my private key, which the only person who has my private key should be me. So that's a clever way that you can use SSH to authenticate an individual. Okay, anyways, enough talk. Ubuntu. So I am going to basically add this SSH key. So now, if I try and connect via SSH, that should work fine. Maybe I should have actually shown what would happen if I tried to connect without first uploading this key. But oh well. Essentially, it'll complain and tell you, hey, what are you trying to do, Buster? You can't do that. Okay, so let me navigate to the repository, the AUV 2020 repository, inside McGill Robotics, and here it is. Cool. Okay, so I'm going to copy this, and here I am in my normal home directory. I usually like to create my own kind of workplace or workspace directory where I put all of like my stuff that I kind of interface with GitHub. This is just like a thing I do. Okay, so let's see. Git clone is the command to basically download all the files. And so here it's saying, hey, do you want to trust this entity? I'm going to say yes. And there you go. It's downloaded. So it would add this AUV 2020 folder. And if I go inside, I will basically see that I have all the same files as I have here. And if I run git branch, it'll tell me you're on branch noetic, which same as this. Okay, cool. So we have all of the software basically downloaded, but it's no good to us like this because obviously we want to build it and run it, and in order to build and run it we need some additional stuff. So what we need is we want a ROS noetic install. So the version of ROS that you need matters depending on the version of the operating system. So as a team, we're currently using ROS noetic, which means that as your operating system, if you're using Ubuntu, make sure that you are using Ubuntu 20 or Ubuntu Focal. If you logged on and see this picture of this cat with laser eyes, then you're on the right track. So, but I believe if you want to check more clearly, I think the command is something like lsb release. Modules are available. No, never mind. I thought that were something similar to that. Anyways, anyway, I know for myself that I am running Ubuntu 20.04, and that is the version that corresponds to ROS Noetic. So, okay. Now we can just go and follow this tutorial. Basically what we need to do. Oh, here it is. Here's the command that I want to run. Basically, if I run this, it should tell me, I guess, what version of Ubuntu I have. And Focal is the code for Ubuntu 20. Okay, anyways. Okay, so first up, setting up your sources list. Sources list is the kind of list that your package manager uses to keep track of all the different servers that it knows of where it has software. You can actually see this if you go, let's see, nano slash, so it's in etc, which is where a lot of config files are. apt is the name of the package manager, sources list. Whoops. I meant to nano it. And there you go. So here you have all these different URLs are servers. And, you know, if we actually click on them, I think that it will take us here. And, you know, you can peruse through this and, you know, find the software packages which you're going to eventually download and install. Okay, but what this does is save buffer, no. Okay. What this does, it adds an extra kind of entry for where our ROS servers, the server that contains our ROS packages, because right now it doesn't really know about that. Okay, and then I'm going to set up my keys. So similar to what I was talking about with GitHub, when you make a request to the server, when you're talking to the server, you want to make sure that you're talking to the actual server and not just some like malicious middleman. And the way you do that is you want to download the server's public key and use that in your kind of initial kind of handshake authentication process in order to determine that yes, you are in fact talking to, you know, packages.ros.org. Okay, so let's run that. And so it says okay. So after we run that, it would have added a key. In fact, we can do sudo apt key list, and you'll see we have this new added key to our keyring that says it is for the Open Robotics, the Open Source Robotics Foundation. So, yep, that's pretty much what we want. And now sudo apt update would update our sources list. Before I run this command, let me show you what happens if you try and run this next command. So sudo apt-get apt install ROS Noetic desktop full. If you run this right now, it says unable to locate package ROS Noetic desktop full because it doesn't know about it. And that is because although it knows about, although it has like a list of all these like IP addresses of the servers, it hasn't like updated the list of packages that it knows about. This is what basically apt update does, is it will send a GET request to each of these server URLs and basically ask it like, hey, what are all the packages that you have? And so, uh, it's going to update kind of its internal list of packages that it knows of. So now, if I do sudo apt-get install ROS Noetic desktop full, this should work. For the purposes of this tutorial, like here you see you have a couple of different options. So this one is basically all the bells and whistles, 2D, 3D simulators, blah blah blah, like RQT and RViz are also like visualization tools. Honestly, a lot of it probably not going to use at the moment. For me and my purposes, I'm going to use this one because I know it'll just take a bit quicker. Although I would recommend that you go with this one, and it's basically this plus some extra like cherry on top stuff. Okay. So let me run that. It takes a while, so I wanted to kind of get the bare bones one so it just doesn't take too long while I'm making this video. Okay. So while that's going, I'm going to talk about one other thing that I want to install in order to build our packages. When I talk about building packages, I'm talking about basically compiling different like C code, making sure that all of like the files are all in the right places, all that stuff. Basically kind of bring your files into a runnable state. And the tool that we use in ROS to do that is called Catkin. So Catkin tool. This tool actually comes, a version of it comes with the thing we're downloading now as a dependency. However, I don't really like it too much, and I tend to prefer this other kind of independent Catkin tool. So again, Catkin is just a build system, and this is a command line tool similar to Git that you would use in a command like catkin build to build your ROS packages. If this doesn't make sense right now, then you'll see it in action soon enough. Okay, so here, first things is it says blah blah blah, this basically does the thing that we just did where it adds the site of the server in fact this is like the same server we just added, so I can just kind of skip this portion, and this adds the key for the server, which we also just did. So we can actually just run this command, and I'll do that in a new tab. And okay, I was expecting this, and I just wanted to show it in case you run into this issue. So it says, could not get locked for blah 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 blah. It's currently held by process something something something. So actually what's happening is that I have this other process running. It is currently, downloading and installing packages, and while it is doing that, it'll basically put a lock on a file. So it'll kind of open a file, and it basically, before it runs this process, it basically tries to open this file. And if it's already opened by someone else, it'll kind of error out. It's just to make sure that it can only kind of perform one operation at a time, so it doesn't get like some kind of like interference between two processes that are using kind of the same resources. However, you might actually come across this error even if you aren't like manually running another kind of installation with apt, and this could be because Ubuntu in the background has decided to run an update. Usually a lot of problems in Linux you can try and fix by just like searching it up on Google. Usually like the first couple of results will give you an idea of what to do. So here this looks like pretty promising. But usually what you'd want is you can list the processes that are currently running with this command, and let me actually do that. this is actually too much information. So what we can do is we can pipe it and say grep apt. And here you'll see this is the command that was run, and this is the process ID, the corresponding process ID. So if ever you okay, sorry. Yeah. Basically, this is the process ID, and if ever you see something like blah blah blah, like auto update, you can actually just kill that process by issuing kill -9 and then the process ID. So something like this. So I'm not gonna issue this command because I want this to finish, but that's something that you can do if you encounter that kind of error. Okay, so let me just clear the screen. Currently, I am waiting on this to finish. In the meantime, I guess I can start talking a bit about this, well, the software, what you would find inside here. I might want to talk about the specifics of the actual programs in a separate video. Right now, the plan is just to build it and run it, but I guess I can just talk about the structure of it. So at the highest level, you have what's called a Catkin workspace. Catkin, if you remember, is the build tool. If we go inside this workspace, you'll see we just have a source directory, and the source directory, in typical programming fashion, is usually where all your source files are, or the human readable files. So if we go inside there, next level we have a bunch of directories. So directories are in blue, and these are called ROS packages. Packages are essentially just buildable entities inside ROS. Maybe I should actually talk about what ROS is. ROS is essentially just like this framework of libraries. So it stands for Robot Operating System, although it's not an operating system in the same sense as like Linux or Windows. It's basically just a bunch of useful tools that are particularly useful for robotics applications. One example is it provides publishers and subscribers, which are a means for two programs or two processes that are running at the same time to trade data back and forth. So you can imagine how this might be useful for like robotics if you have like a sensor and you have some kind of other program that is meant for like turning the wheels or something. You might want one program, the sensor, to send data to the wheels program. So you have both programs kind of running at the same time, and surely you can do this without ROS, but it's a bit of a hassle, seeing as how common of an issue this is, that you don't really want to go about kind of solving it yourself. It's a bit of what we call boilerplate code. So instead, it's much more easy for us to use something like ROS, which has already pre-built solutions for these kinds of problems that we can use just out of the box. So yeah, and then I guess also ROS provides you a bit of structure with like how you design your programs, that you build them around these kind of ROS package entities, which in a sense are just kind of like classes, you can kind of think of them as. Basically, you're able to kind of encapsulate your code into these chunks and kind of build them up. So ROS is kind of like Lego. Okay, I'm just kind of stalling, if you can't tell. This is taking a while, and every time I look over, it's almost done. But now it's actually done. Or no, it's not. Maybe not. I don't know. Anyways, let me open this. And I'm going to just go through this introductory little thing here. So dependencies, we got Ubuntu, we downloaded ROS Noetic, we are going to install Catkin, and once we do that, we can start by building the actual packages. As I talked about, in ROS you have to first build the packages before you can run them, because some of the packages obviously need to be compiled, and all that stuff. Okay, so here I am just downloading Catkin. This shouldn't take as long. Do. Okay, so now we're done. Let me just clear the screen. Okay, so now I want to actually build the packages. So again, let's see, cd catkin source. And the way I have things set up right now is I have this bring up package, which if you build and launch this package, it kind of stands as a proxy for building the rest of kind of the important packages. So that's kind of a handy thing that you can do. So you can do, let's see, the command is catkin build, and then the name of the package is bring up. And it says error, unable to find source space. So the reason for that is because initially it doesn't know about any of the ROS packages. It doesn't know that these are packages, it just knows that they're folders on my computer. However, in searching for a package named bring up, it will try and look for a directory called source in your current workspace. So right now, if I actually go up a directory, here I have a directory called source. And so now if I run this, here's able to find the source directory. Okay, and it errored out there. Okay, so here it is complaining. It says blah blah blah, found 0 of 7 packages succeeded. Okay, what's going on? So the thing is, your workspace is not extended any other result space, blah 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 blah. Usually, if you have these kinds of errors, and let's see, one package of errors, no CMake C++ compiler could be found. CMake list.txt. Okay. Usually, if there are some kind of issues where it says like, oh, the path variable, or I don't know about this like environment variable or that environment variable. Usually, a thing to try first is to source your setup. And so, initially, when you install ROS, you will install this file in opt-ROS noetic setup.bash, which if you run, it will set a bunch of environment variables for you. And you'll actually have to rerun a similar file when you rebuild your packages. So I suspect that this might fix the issue. Let's see. If I try and build it now. Okay, it's still not... It still doesn't know about this C++ compiler. Let's see. No CMake C++ compiler could be found. Okay. So... I haven't come across this issue before, but all's well and good. I guess we can just try and debug this. My first suspicion is whether I don't have a dependency that I should have gotten from installing the desktop full version, although I kind of doubt that. Might as well just run this anyways, although I seriously doubt that I'm supposed to be getting the C++ compiler from here. Anyways, so let's see. No CMake C++ compiler could be found. Tell CMake where to find the compiler by setting either the environment variable C++ or the CMake cache entry, blah blah blah, to the full path of the compiler. Okay, so let's see. Let's see if I have a compiler installed. Version. Okay, I do not. I guess, or hmm. Let's see. I guess maybe I could try and download this compiler here and install it. Oh yeah, honestly I find it a bit weird that I don't have something like this just straight out of the box of Ubuntu, but oh well. Hmm. Yeah, my first thought is I'm going to just try and install G++, which is a compiler, and then I'm going to try and run the setup again. All else fails, I'm going to manually adjust this environment variable, although I imagine that when I install it, it'll automatically update that for me. So let's see. Here, is this almost done? Nowhere close. It is nowhere close to being done. Just for the sake of it, let's actually see if this error I can find somewhere. You should try installing Build Essential if you haven't done so. Okay, yeah, so maybe I imagine Build Essential is something that is potentially a dependency of all of this stuff. Because when I've done this before on other computers, I don't think I've encountered this issue. But anyways, I'm going to try and maybe just stop this process. Okay, let's see. Processes. Grep apt. So here I have sudo apt install ROS Nomadic Desktop full. And then I'm going to just kill this process. And it seems like I have another one that is similar. I'm just going to kill that one as well. Oh, right, okay. Let me try and do sudo. Okay, so now that should be terminated. Perfect. Okay, so let me instead try and install these Build Essential. apt-get install Build Essential. And now that I think of it, this probably sudo dpackage configure to correct the problem. Okay, so let me see this. Yeah, so maybe I just mucked around a bit here. Just killing this process willy-nilly must have, you know, kinda, you know, oh, here it is, by the way. Build Essential, which probably was a dependency, in fact. The more I think of it, the more it kind of makes sense to me, that this is a kind of bare bones installation, and basically it assumes that you've already have maybe built your ROS libraries and you just want to run them, perhaps. I'm not sure. But either way, this is taking a while. Maybe it would have been better to just let it finish. Anyways, sudo apt get install, let's see, build essentials. If you do what I said and just install ROS Noetic Desktop full, you're probably not going to bump into this issue. I'm making it look more complex than it actually should be. And this would not work because I currently have this program running. And I guess maybe I should just pause it and return when it's done, because it looks like it might take a while. Okay, so it's done now. Let me just check. Let's see, build essentials. I don't know if this... no, okay, I didn't expect that to work. I'm wondering if I could see if how this works. But anyways, okay. Let me install build essentials. Unable to locate package build essentials. Okay. Sudo apt get update. Okay. So this is quite interesting. Let's see. Build essential. Okay. I was looking for the wrong package. Let's see. One upgraded. Blah blah blah. Here to unpack. Build essential set to manually installed. Is already the newest version. Okay, so that must have actually installed build essential already. But, you know, I'll let it finish anyways. Okay, perfect. So, again, I'm still in my Catkin workspace, and I'm going to run catkin build bring up. You also might have noticed that whereas before I just had this source folder, now I have build development logs. And these all were generated during this catkin build process. Essentially, what it would do is it would create this build directory, then it would go inside that build directory and do all of like the compilation and stuff inside there. That's not quite right, but essentially there are some kind of artifacts of the build process that it doesn't want to kind of populate the source space with, and so it just stores them inside build. And I'm going to continue talking about those a bit later, but first, you might encounter an error like this. So it's saying, hey, I want to do some configuration for a PID package, basically. But I don't know about a PID package, and the reason it doesn't know about a PID package is because I don't have that installed. So there's like a bit of mention it here. It says, oh, you also probably need package-specific dependencies. This is kind of what I mean. So usually the nomenclature for installing these is you do sudo apt get install, and then it would be ROS version, in this case Noetic, and then the name of the package that you want to install, so in this case PID. And if ever you're unsure about the name of the thing that you'd want to install, another thing that you can do is you can run apt cache search, which will search your kind of computer's list of packages that it knows, and you can search something like, let's say, PID or ROS PID. And so here it'll give you some results, and you see here ROS Noetic PID. It's the thing that we want. So if you kind of have to, I guess, have an inkling of like which one of these is the correct thing you want. But yeah, this this is what we want. Okay, so now we can try and build it again, and we should not get that error anymore because now we have this PID package installed. However, you could maybe have some other dependencies that are not installed on your computer. And you might ask at this point, like, okay, what's the point of all this? Wouldn't it be easier if it just kind of determines what packages aren't installed and then go and download and install them automatically? Yes, that would be too simple. The reason, and I think there is a tool for that called raw step. You can use that if you like, but I've had some issues with it in the past, and so my preferred method is this trial and error where I keep trying to build it, and every time it fails, I look and see if there's a new package that I need to install. So raw Arduino, if you don't know what this package might be called, you can try and search for it. So let me try and do it as such. So here I believe it actually won't find this particular name. It's always good to use like spaces instead of, it'll treat this as like a single kind of word. And here it says, gives us this result, ROS Noetic Raw Serial Arduino, which is the package that we want. It's the package that allows us to basically talk back and forth with our, here I want to install it. apt-get install. Yeah, it's the package that allows us to communicate back and forth with our Arduino via serial port. Okay. And I guess since I'm mentioning it, the PID package, it's a bit much to explain for right now, but PID controls, there's like a Wikipedia page on it. If you ever want to read what a PID controller does, I might be explaining it in like a future video, but yeah, this is just like a package that implements a PID controller. Okay, so I guess I was talking about before, right? I was talking about the different workspaces that get generated. So, how I have a source directory, a build directory, a devel directory, and then a logs directory. So logs, pretty kind of self-evident, is just like, just puts a bunch of log files with any kind of errors or, you know, messages in there. That's where a lot of them might be stored. The messages like during the build process. Build is where it'll put a lot of like build artifacts, you know, things like make files and you know, just things like that, I guess. Devel is where it would put all of the results of the build. So the compiled files, you know, any like, you know, Python files or anything, like that's all of like the runnable kind of state programs are going to go into Devel. Okay, and we're done here. So let's try again. Catkin build bring up. So you'll notice that Catkin is basically this kind of tool that builds things recursively. So it'll check and see that bring up depends on these other packages, and so it'll build these packages first. So it built AUV messages, it built controls, it built planner, it's building propulsion now, and then it'll also build state estimation. And so, yep, here it gives this warning. It's okay if you see this, it's not a big deal. Yeah, it's fine, you can just ignore this particular warning. Here, okay, you know, just another package that we don't have, so let's just install it. Sudo apt-get install ROS Noetic Smatch. I'm just gonna guess that that's what the name is. Alright, hopefully this is the last time I have to install this particular piece of software. Hopefully the next time that I run the build, it should be all good. Yeah, and I was thinking of like maybe having a file, like a shell script that you can run that'll automatically kind of install all these things for you, so you don't have to bother with, you know, running it every time and seeing. But it's okay, you only have to do it once, so it's fine. Anyways, summary. All 6 packages succeeded, blah blah blah. One warning, the warning's fine. Let's see, cmake toolchain file. Were not used by the project, blah blah blah. Anyways, that's fine. So at this point, what you can do is, if you have a Arduino connected, you can flash the Arduino, and I believe I actually do have. No, I don't. I don't have one connected. If you were to try and run this, it'll basically complain and say, "Hey, you know, you." it'll like error out. But yeah, if you have an Arduino connected via USB, you would be able to basically upload your code onto there. And so now, basically we have all of the things built, and we're ready to run the things on our machine. If we try and do this now, however, we'll run into an issue where it says, hey, stub.launch is neither a launch file nor a package, blah blah blah. Basically, it doesn't find this. The reason is, here, when we ran this first build, it told us, I believe at the very end, or maybe it should have told us somewhere, that our environment has changed and that we should resource our workspace. And the way you do that is similar to how we source that ROS opt setup.bash. Now there's a new setup file, and it's in this devel directory. So you can run source devel setup.bash. In fact, here I am not inside the source directory, so I should be able to just run this. Okay, and now let me try and launch this ramp file. So launching a file would be basically executing a bunch of programs simultaneously. It's just like a convenience method, so you don't have to start each process on its own, because there's a couple of processes that are having to run all at once. So yep, you can see here basically it said blah blah blah. I'm going to set all these parameters. Here are all of the running nodes, all this stuff, and then it goes into the state machine and adds all the states, and adds all the transistors for them, and then says state machine starting in initial state submerge, which is the first state where it just is trying to go down to a particular depth. So if you see something like this where it says waiting for first set point, this is a bit of a bug right now in the bring up package, in that the order in which the packages are brought up kind of matters. So for now, I'm actually just going to kill this process, and I'm going to just restart it and hope that you don't encounter this issue. This is something that should kind of get addressed, but for now I can kind of just try and launch it again. Or let me actually take a look here. So here it's all gone. ROS node list all. Okay, so yeah, it's all gone. Stub.launch. Okay, here in the meantime, let me go here. By the way, because this is a separate shell environment I have, each tab is a separate shell environment. Here I would need to resource the space again, because here if I try and, for example, do something like ROS topic list, won't basically know what that is. So let me do source devel setup.bash. So now if I do ROS topic list, it'll tell me all the ROS topics that are currently kind of up and operational. And then I can do the same with ROS node list. So these are all of the nodes that are currently running. Okay, so I was having a lot of issues just trying to get it to run normally, so I went and did some hacky things to have things like kind of brought up in the correct order. Definitely gonna need to get fixed in the future, but anyways, let's see. Gonna get into here, catkin workspace, and I believe I already have the brand package built, but I'll just build it anyways now. Catkin build bring up. Okay, successful. Next I'm gonna source the setup. So it's in devel setup.bash. Oops. Okay, and now the command to launch the mission, or the stub mission, is ROS launch bring up dot launch. The little ampersand at the end just makes it run in the background so I can execute commands. Actually, I'm just gonna run it in the foreground. That's perfectly fine. Gonna run it in the foreground and then gonna open a new tab. Let's see, was there an error somewhere there? Error opening serial could not open port, blah 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 blah. Okay. Oh right, wait a minute. No. Let me shut that down. Let's see, which thing did I run here? Cat can build bring up. Bring up.launch. Yeah, sorry, that's the incorrect one. This is the actual mission, and this is like the stub mission. The difference is just that you don't. I guess it doesn't include like the Arduino and like the other firmware components. So you're gonna have like the error here where it's like complaining that it doesn't have like serial communication with the Arduino because there is no Arduino right now. I'm just running it off my computer. So yeah, that was the wrong thing to run. Let me actually just make sure I have everything up to date. Git pull. Okay, it's already up to date. Cool. Okay, so this is the thing to run. Paste. And in this other shell, I'm going to make sure I run the setup file. Source setup devel setup.bash. Okay. Let me detach terminal. And here. I just want to try and set this up so I can. Okay, I was trying to get it to have like a split there, but whatever. Anyways, okay, so here everything started properly. It added all the states for the state machine, and now it says state machine started in initial state submerge. So this is just the state where it goes down to a depth of, I believe, 4 meters is the submerged depth. Essentially, the stub mission right now it just comprises of descending to 4 meters depth and then going back up to 2 meters and then just going back and forth. So yeah, let's see, it's waiting for the first set point message, and I can try and like sub that. Let's see. I believe there is an example of what can be done inside controls. Go here. So this is an example of a state message that you can publish. So let's see. So if I publish this, I'm publishing, so it's kind of like as if a depth sensor sensed that I am at 1 meter depth. So once I'm published, I shouldn't get this warning anymore because I've officially like published the first state, and it's waiting until it gets to 4 meters depth, or around that area. So let's say we go to like 4.05 meters, and then here it says info state machine transition submerge to ascend. So ascend would wait until we're at 2 meters, and then it goes back to from ascend to descend now. Okay, so it's just one more. I think it's a 4 meters depth, or maybe it's 6 meters. I'm not sure. Yep. Okay. So yeah, it just goes back and forth between the ascend and descend state. This is just like just I guess just show off like the capabilities of the state machine. So okay, I'm just going to kill this off now. Just Control C, and let's see. Ross no list. I think it should be all done. Nope, it's still there. Okay. Oh, actually, I know why. Because I think I ran it in the background. So if I jobs, yep, it's still running. Okay, yeah, but if I were to, let's say, do like a Ross node kill, let's see, pursue target, which is the action server. Success descend. Okay, anyways. Yeah, anyways, you can like play around with all this stuff. I'm gonna be explaining maybe in another video how the like software in each of these packages actually works. Obviously it's getting worked on at the moment, so it's pretty bare bones, but I think it still kind of gives you a good intuition of like what's going on. So yeah, here I'll just kill it, and on exit it will transition into the failure state, which is the final state of the state machine. Okay, so yeah, that's about it. And I guess my plan for the future is just to, I guess, individually go through each of the packages and talk about a bit about like how they're implemented at the moment, as well as talk about, I guess, like the architecture as a whole, how things are gonna evolve or potentially evolve, and yeah, potentially show like an implementation of a package, perhaps. All right. Anyways, I don't know how to end this. Bye.